Welcome to another episode and video on my Arduino Yun with electronics, and more specifically vision technique motors controlled by, of course, AVR-C and output via SSH terminal, and everything to be checked via oscilloscope. Left side, this is the left side potmeter, this is the right side potmeter. This is pulse width modulation right here for this motor, and this one indicates pulse width modulation for this motor. Now, last time it became clear that things don't work as should. Also, that changing motors revealed short time improvement, but also that this motor is partly controlled by how this motor is being controlled, and that is rather weird. This button has immediate control over this one, considering or in a situation that the level of this potmeter is low enough. This one has a temporary effect, the same temporary effect on this one, but it is temporary, it doesn't always work. So now I want to find out why is this motor not being affected by this potmeter in the same way that this one is affected. I checked the code last time, but not to very much success, so let me enter everything. Well, everything, just there we are. And this is exactly what is being shown. This motor starts immediately, uncontrollable as it seems. Now I do have, as you can see, with the blue line being up and down as being the potmeter, you can see that the pulse width is being controlled, but that's all you can see. And when it is low enough, pressing the switch doesn't hold it. And let me not forget to give input. And now I'm actively pressing the switch. I should actually put this window right here so you can see what my hand is doing. Pressing the switch, indicated by this light by my finger, and now I can't measure anything anymore because I pulled out this one. Alright, am I good? Yes, I'm good. Then another thing is, of course, alright, now why don't I see any pulse width from here? That's a bit weird. I should be seeing some pulse width right here, and I don't. So let me turn it up, and I still don't see anything at all. No, that is because it is in the wrong lane. Now I should see something. Yes. See, that works better. So now let's see once again. The time base is not what it should be. Alright, a little better. So now things have been adjusted. Time to find the error, if I manage this time. Alright, checking the code reveals nothing wrong or spectacularly wrong. So I am checking something else with code being correct, and what already was shown is that if you mind the left side propeller, you can quite easily see how the turning of the potmeter influences the speed of the propeller. And also if you look at the yellow line and the purple line, third line from second line from below, you can easily see how the potmeter influences everything. So now focus on that propeller and this potmeter. So still giving input, and you can easily see that there is absolute response. So the higher the blue line, second from above, then the signal below, the first from below, so actually this here changes with it. The only difference is, well, not quite. If you pay very close attention to the right side propeller, you see a change in speed. But even if I put it absolutely low and the pulse width modulation is next to nothing, propeller doesn't stop. And I just checked on the power controller, the visiting power controller, which operates at a constant voltage of 9 volt, and with turning the knob you change the pulse width modulation frequency, and with that power controller I can just quite easily have it run full speed and everything between 0 and it can't let stop. So what is wrong with this? Obviously this circuit operates perfectly, but what's wrong then with this circuit? That is the big question. One thing is obvious is that this LED burns very bright, and this one is merely blinking. But let me change some value. Let me look closely at that LED. And there's no change. There's virtually no change. Well, not entirely true. When I have it at its lowest, then the LED is either off or very slowly burning, lowly burning. And when you turn it up, the blinking goes very fast. But that doesn't explain anything. Another thing is, of course, and I also tried to check that last time, is what is the frequency anyway? Because you can easily see that these frequencies are not the same. If I turn it completely up and I turn this one completely up, you don't see the same thing. This signal and this signal are really different, and they are really operating at 2 milliseconds. Well, the time base is 2 milliseconds. But is that really the cause of this circuit to respond so differently? I can't believe that. So, what to do? So, with these differences in behavior, I am looking now into the schematics of the Arduino Leonardo, which is considering the pins exactly the same as the Arduino Yun, which I am using. So, both motors are being connected through different pins. So this one is using through wiring pin 3. This one is using through wiring pin 11. No, pin 6, excuse me, pin 6. Now concentrating here, pin 3 is register OC0B. Pin 6 OC4D. Now then it is nice to say, alright, which one also has OC4D? Well, this one, pin 12. And the other one, not really, except that this one has a bar over it, which indicates it is the inverse. Well, I don't care if it is the inverse, it should more or less behaving the same way. So 1 is 0, 0 is 1. So what if I change pin 3, or not change pin 3, change the wire from pin 3 to pin 12, and see how that will behave. It's a long shot, but who knows. So going here, then I will need to find out if and there's an ouch. Is pin 12 actually being able to do pulse width modulation? And there the answer, I'm afraid, is no. So, going back, if pin 12 is not available, which one is? A very good question. C4D, this one is inverted. C4A, I can go to pin 13, see whatever that brings. But I'm afraid this orange wire isn't long enough, but maybe I can, looking at this wire, it just may work. So let's change for pin 3 to pin 13, which is then where exactly? Yes, so I am changing this one to 13, this one to 13, and I will have to do the same here. Not sure what goes wrong here, but pin 13. What else do I have? Nothing else actually. Okay, replaced by 13. And let me do that here as well. Replaced by 13. There's no other analog out pin 3 to be found. Oh, there is, by the way, here, but it's not connected. It's not connected. So this means that I have to. Oh, that's a nice one. While analog out pin 13 definitely is not connected. So how does this work then? That's a good one. I may not be able to use it. My plan goes into void. Totally void. Right, what's the solution? Right, so I am not sure why analog out pin 13 is being used in this part, and for that matter in this part, and not being connected. So for now I am going to disable them. With command used for sensor value 2. Whatever the whatever the consequences will be, I have no clue. So with that said, I am going to try to change this wire first. No, I have to let it be here. Going here. Now you see that this stops because it is disconnected from 3. So I have now to upload, and yes, I have also to connect. Then this one is being connection closed. And this one, and now this one is running again. So logging in, giving input, and now is the question, what will happen, if anything? And this is no good. Not just this one keeps running, but the signal, this signal is not what I want to see. This is not what I expect to see from pulse width modulation. This is, but not this. So how am I controlling pin 13 anyway? Output value 2. But output value 2 is 0. So how am I controlling the left side motor? Here I am sending 2. And output value 6 gets output value 1. Output value 1. Alright. Now where is output value 1 coming from? Here. So I should say output value 3 should be designated or should be assigned to 13. Sensor value 2. So copy. Come on. Paste. Here the same. Oops. No. Yeah, it is. It is. So let's see how this works out. I'm very curious. Right, final part of this video, and let's see if anything has changed. And if so, what? Well, that is what I expect to see. Right here, kind of. But can I take it down? Pushing the button. Pushing the button should be a total down. Let me lower this. Totally down. No such thing at all. Left side motor, totally controllable. Not even a question about it. Right side motor. Not totally controllable at all. It is better, but still no such really. I stand corrected. Except that it is totally inverse. So when I press it now, yes, press it now, right, a little bit lower, pressing, no such thing. I can only say this is a very big improvement. So the functions are totally inversed. Although I do not get exactly why. But for now I'm happy with the result. Yes, happy with the result. So thank you for watching. If you like this video, please subscribe to my channel if you haven't done so already, and like the video. Follow me on Twitter retweet and like, follow me on Instagram and like, and please donate to keep the videos coming. More information on my website, and well, things do cost money. It's as simple as that. And this is to be continued. So, bye bye.